Welcome to this explainer. Imagine a world entirely without clocks. Literally no hours, no minutes, no ticking seconds, no schedules or looming deadlines, just the sun rising, the sun setting, and life just flowing naturally. Sounds kind of peaceful, right? But, well, humanity didn't stay there. We went from watching simple shadows in the dirt to measuring billions of a second with unimaginable atomic precision. It's absolutely one of humanity's greatest achievements, and I cannot wait to guide you through exactly how we pulled it off. Okay, let's dive right into this with a question that might seem a little, counterintuitive at first glance. Who actually invented time? Was it some powerful ancient king demanding a strict schedule? A brilliant early scientist? Or maybe a really deep-thinking philosopher? Well, the answer is nobody. The surprising truth here is that time itself was never actually invented by us. Time has existed since the very beginning of the universe. What humanity actually invented was the measurement of time. We didn't create the flow of the river, right? We just figured out how to stick a ruler in it. According to modern physics, our universe kicked off about 13.8 billion years ago with the Big Bang. At that exact moment, space and time emerged together, woven into what Albert Einstein would later call space-time. Stars were born, they died, galaxies collided, all over immense, mind-boggling spans of time, long before anyone was around to count the seconds. It actually wasn't until about 300,000 years ago that early humans started noticing patterns. The moon changing shape, the seasons returning year after year. Back then, a day was just one sunrise to the next. But then, around 5,000 years ago, everything shifted.
Part 1. Reading Nature's Clock, the Agricultural Push.
So, why did we actually start tracking time? Well, it basically comes down to farming. As agriculture developed, humans faced a massive problem. They desperately needed to predict the seasons to know exactly when to plant and harvest their crops. The ancient Egyptians looked up to the sky and noticed that the star Sirius appeared right before sunrise, just before the Nile River would flood. Using this incredibly reliable natural marker, they developed one of the earliest known calendars around 5,000 years ago, containing exactly 365 days. It was remarkably accurate. At the exact same time, civilizations over in Mesopotamia were creating their own complex systems. Humanity was no longer just passively experiencing time, we were actively organizing it. But as you can imagine, measuring the year just wasn't enough anymore. As civilizations grew, people needed to measure parts of a day. Enter the very first clocks. Now, sundials were brilliant. They used a simple stick's shadow moving across the ground to estimate the time. Ancient Egyptians and Babylonians used them to chop daylight into smaller sections. But sundials had one fatal flaw. They completely failed at night and, well, on cloudy days. To solve this, ancient societies invented water clocks. By measuring water slowly emptying from a container through a tiny hole, time could be tracked continuously. And these weren't just simple buckets either. In places like Egypt, Greece, China, and India, they evolved into highly sophisticated devices with gears, moving figures, and complex mechanical displays.
Section 2. The Mechanical Leap. Standardizing Civilization. Now, before we look at the machines themselves, let's talk about the math for a second. Have you ever wondered why there are exactly 60 seconds in a minute and 60 minutes in an hour? I mean, why not 10 or 100? Well, the magic number is 60, and this traces all the way back to ancient Mesopotamia. The Babylonians used a base 60 numbering system thousands of years ago, which, by the way, also divided circles into 360 degrees. Later scholars just applied these exact same divisions to time. So, pretty crazy thought here. Every single time you check your watch today, you are actually utilizing an ancient Babylonian mathematical concept. Fast forward to the Middle Ages, specifically the 13th century. Trade was booming, cities were growing, and people really needed continuous, accurate mechanical clocks powered by weights and gears instead of water. But they still weren't perfectly accurate, often losing chunks of minutes every single day. Then came this massive aha moment. In the late 1500s, Galileo Galilei was just sitting in a cathedral, watching a lamp swing back and forth. He noticed it took nearly the exact same amount of time to complete each swing, regardless of how wide the swing actually was. This observation of the pendulum principle was an absolute game changer. Decades later, in 1656, Dutch scientist Christian Huygens took that principle and built the first practical pendulum clock. Just like that, errors dropped from minutes per day to mere seconds.
Part 3. Time as a Tool, Empires and Industry.
During the age of exploration, sailors could easily use the stars to find their latitude. But longitude, their east-west position, now that was a deadly mystery. Solving it required highly precise timekeeping. In the 1700s, an English clockmaker named John Harrison stepped up and developed marine chronometers. These were clocks that could finally stay accurate on really rough, long sea voyages. This completely changed global navigation, allowing empires and trade to expand rapidly. Then, in the 19th century, railways introduced a totally new crisis. Before trains, every little town just had its own local time, based on the sun. But when fast trains started connecting distant cities, these local times caused massive confusion and, quite literally, train accidents. To stop the chaos, the world was forced to adopt standardized global time zones. The clock wasn't just measuring the day anymore, it was organizing global civilization.
Section 4. The elastic second. Einstein and the atom.
So, for centuries, scientists firmly believed that everyone, everywhere, experienced the exact same time. Then along comes Albert Einstein. His theory of relativity proved that time is actually entirely flexible. We call this time dilation. It literally means that a clock moving very fast runs slower than a stationary clock. And a clock near a massive object with strong gravity, it also runs slower. This absolutely shocked the scientific world. Time wasn't this fixed, rigid thing, it was stretching and bending based on speed and gravity. Time was just far stranger than anyone had ever imagined.
And because time is a physical part of the fabric of the universe, scientists eventually realized they could measure it using the building blocks of the universe itself. We finally moved away from mechanical clocks, with their gears and pendulums that lose seconds every day, and we invented atomic clocks. Instead of physical gears, atomic clocks measure the completely consistent vibrations inside atoms, most commonly cesium. The precision here is almost impossible to comprehend. Get this, an atomic clock loses less than 1 single second over millions of years. These incredible machines are what now define the official international second.
Now, you might be thinking to yourself, okay, why do I care if a clock loses a second every million years? Well, actually, you use it every day. Every time you use GPS navigation on your phone, you are heavily relying on atomic time. GPS satellites orbiting the Earth carry atomic clocks on board, constantly broadcasting timing signals. Your phone figures out exactly where you are by measuring the tiny, tiny differences in the arrival times of those signals. If those atomic clocks were off by even a billionth of a second, your GPS would completely fail and probably place you miles away from your actual location. So yeah, our entire modern world depends absolutely entirely on this extreme atomic precision.
Part 5. The ultimate mystery. Time's arrow.
All right, here is the really big question. If time is so flexible, why does it only ever seem to move forward? I mean, why do we remember the past, but not the future? Scientists call this the arrow of time, and the best explanation we currently have involves something called entropy. Entropy is basically the measure of disorder in a system. The laws of physics dictate that over time, disorder naturally tends to increase. Think about it like this. If you drop a glass, it shatters into a chaotic mess on the floor. But those shattered pieces, they will never, ever spontaneously reassemble themselves back into a perfect glass. That physical direction, moving from order to increasing disorder, is what gives time its forward flow. It's literally the very thing that separates the past from the future. When you really look at it, the story of time is a story of humanity's relentless attempt to understand reality itself. We evolved from just watching shadows creep across the dirt all the way to measuring the microscopic vibrations of cesium atoms, and we're definitely not stopping anytime soon. Scientists are currently developing optical atomic clocks that are going to unlock even greater precision. Yet the deepest questions still remain wide open. Did time truly start with the Big Bang, or is there some deeper structure beyond our current understanding? Time governs our planets, it shapes our history, and it dictates every single moment of our daily lives. Yet its fundamental, true nature remains one of science's greatest mysteries.
We've learned to slice time into fractions so tiny, they honestly challenge the limits of human imagination. We can measure it almost perfectly now. But as the clocks just keep ticking and the universe keeps on expanding, we're left to wonder, will we ever truly understand what time actually is?